Hey everyone, today we are going to solve the Daily LeetCode challenge of 8 January 2024, and the problem statement is range sum of BST. So let's first understand the problem statement. So according to the problem statement, we have been given a BST and two integer values, low and high, and we have to find out the sum of the values of all nodes that are in the inclusive range of low, high. Now, what do I mean by an inclusive range? Inclusive range means, say for example, if in a BST we have a value as 7, then we are going to add that 7 in our sum as well. And if we have a value as 15, then we are also going to add that 15 in our sum. It means that we are going to also include the nodes that has a value of low or a value of high in our sum. As you all know that if we have a BST, say for example, this is A, this is B, and this is C. So for this to be called as a BST, the value of A should be greater than its left child and it should be lesser than its right child. Then only we can say that this is a BST. So as you can see over here that the value of 2 is greater than 1 and is lesser than 3. The left child of 2 is lesser than it, whereas the right child is greater than it. So it is following the property of a BST. Additionally, we can also see over here that the left child of 5 is smaller than it, whereas the right child of 5 is greater than it. Similarly, the left child of 10 is lesser than it and its right child is greater than it. So they are following the property of a BST. Okay. Now, the question is, how are we going to solve this problem? So say, for example, if my root is null, then in that case, will I get any sum? The answer is no. If my root is null, then it won't contribute to my sum. So I'll return a 0. Okay. Secondly, if the value of root is lesser than low. So let's see over here. You can see that the value of low is 7, whereas the value present over here, this node is 2. So this 2 is lesser than 7, right? So is there any point of making a left call? The answer is no. Why? Because this 2 is lesser than 7. So any value which is present in the left of 2 will obviously be lesser than 2. Say for example, instead of this 1, there is any number m. So this m is less than 2 and this 2 is less than 7, that is low. So eventually this m is also less than this low. So there is no point of making this left call. So we will prune this call. Okay, we'll cut this call. We won't make this call. So if the root's value is lesser than low, so it means that it is not falling in our range of low to high because it's lesser than low, right? It's lesser than low. So it won't fall in this range. So what we are going to do is we are not going to make a left call. So we'll simply make a right call. So in this case, what we'll do, we'll make a right call. Thirdly, if my root's value is greater than right. Okay, so let's see over here. This is 18, right? This is greater than the value of my height, 15, right? So for this root, we won't make any right call. Say for example, if here I would have a value as 20. Okay, so in that case, we won't make any right call. Why? Because this 18 is greater than high. So if there is any value towards the right of 18, that would also be greater than high. So there is no point of making any right call because it will fall outside the range of low, high because it would be greater than high. So we are not going to include it in our sum. So what we'll do, we'll make only a left call. We'll make only a left call. Why? Because the value present on the left side are lesser than the node. So there is a possibility that we might find a value over here. We might find a value over here that is lesser than 18 and it's falling in the range of low to high. So we'll make a left call. Now coming to the fourth point, if my root's value is not less than low and it's not greater than right, then what does it mean? It means that it's falling in the range of low to high. So it means that my root's value is greater than equal to low and then my root's value is less than equal to high. So in that case, what are we going to do? We are going to add this root's value to our sum. So we will add this root value and we'll make a left call and we'll make a right call. Okay, so we will make a left call and we'll make a right call. So this is all which we'll be doing. Now let's do a quick dry run on this test case. So we will start from our root node, which is this one. And now we'll check, is my root null? So it's not null. Then I'll check that is the value of my root lesser than low. So is 10 less than 7? No. Then I'll check, is the root's value greater than right? So is 10 greater than 15? No. So we are falling in the fourth condition, which is that my root's value is greater than equal to low. So 10 is greater than equal to 7, and then my root's value is less than equal to high. So it means that it is lesser than equal to 15. So the fourth condition is true. So what we'll do, we will add the value of root to our answer. So say for example, if this is my answer, I'll add 10, and what I'll do, I'll make a left call and a right call. So first let's make a left call. So I'll come over here. Now I'll check, is this node null? So it's not null. So I'll move to the second condition. Is its value less than low? So is 5 less than 7? So it's true. So what we'll do is we'll make a right call. So we will make a right call, and now we are here. Now again we'll check, is this node null? So it's not null. So we'll come over here. Now we'll check that is the value of 7 lesser than 7? So 7 is not less than 7. So control will come over here. Now we'll check, is 7 greater than 15? So 7 is not greater than 15. So we will reach to the fourth condition, that is 7 is greater than equal to 7 and it's less than equal to 15. So what we'll do, we'll add the root value to our answer. So we will add a 7 and we will make a left call and a right call. Now, when we'll make a left call, we'll reach to this null, right? So we'll check, is our root null? So it's null. So we will simply return a 0. Now, when I'll make a right call, what I'll find is, it is also null. So we will come over here, we'll say that is my root null? So it's null. So we'll simply return a 0. So from here, we will be returning 7 because this was left call plus right call plus root's value. So root value was 7 and the answer of my left call and the right call was 0. Okay, so now we are done for this right call. Now, as you can see that since the value of 5 was lesser than low, that is 5 was lesser than 7, so I didn't made any left call. So it means that this complete subtree got pruned, it got cut off. We didn't check for this because since 5 is only less than 7, so all the values which would be present over here in the left subtree of 5 would be lesser than 7 because that's the property of a BST. So in this way, we have made our calculation less by following the property of a BST because we didn't made any call for this subtree. Okay. Now we'll come to this node. Now we'll check, is this node null? So it's not null. Now I'll check, is this value less than low? So is 15 less than 7? No. Now I'll come over here. I'll check, is 15 greater than 15? No. So we'll reach to the fourth condition, which is 15 is greater than equal to 7 and it's less than equal to 15. So what we'll do, we'll add this root. So I'll get a 15 over here and we'll make a left call and a right call. Okay. Sorry, this would be 18 over here. Okay, it got erased. So the moment we'll make a left call, we'll see that we don't have any node over here. So it means it's null. So we'll check, is my root null? So yeah, it's null. So we'll simply return a 0. Okay. Now we'll make its right call. So we'll see that it's 18. Is that root null? No, it's not null. Now I'll check, is 18 less than 7? No, it's not less than 7. Now I'll check, is 18 greater than 15? So yeah, 18 is greater than 15. So what we'll do, we'll make a left call. Why? Because see, this 18 is greater than 15. So there is no chance that any value which would have been present in the right side of 18 would be lesser than 15. Why? Because in BST, all the values present at the right side of a node is always greater than the current node. So since this is 18, then all the values which would have been present in its right side would obviously be greater than 18. So there is no way that it would fall in the range of 7 to 15. Okay. So we'll make a left call. The moment we'll make a left call, we'll notice that we have reached to a null, right? So since this is null, we'll return a 0. Okay, so from here we'll get a 0 and from here we'll get 15. Why? Because here what we were doing is we were adding the root value and its left and right call. So from the left call we are getting a 0, from the right call we are getting a 0, so this will return 15. Since we have completed our recursion, so let's see what is our answer. So our answer would be 10 plus 7 plus 15, which is nothing but 32. So this is our answer. Now let's quickly code this problem. So let's start by creating a different function. So let's create a function find sum, and it would give us the sum, which would be an integer. So its return type would be int. And we'll be passing the root node, low, and high. So the first case would be that my root is null. So in a case when my root will be null, so it won't contribute to my answer, so we'll simply return a 0. Now the second case would be that my root's value is lesser than low. Okay, so if my root's value is less than low, then there is no sense in making a left call. Why? Because since my root's value is less than low, so any value which would be present in the left side of root will also be lesser than this root value, and eventually it would be lesser than this low. So in that case, we'll simply make a right call. So we'll say find sum roots right, and we'll pass on the left, low, and high. Now, the third case would be that my root's value is greater than high. Now, in a case that I get a node whose value is greater than high, then for that particular node, we are not going to make any right call. Why? Because all the value which would be present towards the right of this node would be greater than this node, and it would be eventually greater than this high. So we will make a left call. We'll pass this low and high. Otherwise, if my root's value is neither less than low nor it is greater than high, then what does it mean? It means that it is falling in the range of low to high. Means my root's value is greater than equal to low and it's less than equal to high. Okay. So in that case, what we will do? We will simply add our root's value and we'll make a left call. We'll pass the low and high and we'll make a right call. Okay. So let's say that here we are going to return find sum and we are going to pass the root, low and high. Okay. So now let's run this code. So it's giving the correct answer. Let's submit it. So it got accepted. Talking about the time complexity and the space complexity, the time complexity is order of n. Why? Because in the worst case, all these value of my tree can fall in the range of low to high, right? So we would be including all of them. It means that we will be traversing over all of them. So in the worst case, the time complexity would be order of n. And talking about the space complexity, we are not using any extra space from our end, but because we are making use of recursion, so behind the scene, it's making use of recursive stack. So it will cost us an order of h space complexity, where h is the height of the BST. Now, so in this case, our height of the tree is nothing but n, which is the total number of nodes. So in the worst case, the height of the tree would be n. So the space complexity could also be order of n. So that's all for today's daily LeetCode challenge. Thank you.